If you, like me, benefit from working almost exclusively in the 3D viewport, but would like to Z order and distinguish maybe VFX or different elements of your animation to be closer to the camera without doing too much math, I have a geometry node solution for you. Feel free to find it for free on my Ko-Fi page. The Blender giant upon whose shoulders we stand today is a Alan Wyatt 3D or Tradigital here on YouTube. I highly recommend subscribing to his channel for product updates as well as his Discord just for a really smart community of 2D-esque visuals in this Blender 3D space. Cool guy. Make sure to thank him for me. So to jump into just showing how this works, we've got a factor that will flatten our object straight to a camera. Notice that this does erase a lot of normal data, as well as hopefully intuitively we understood that when we're flattening it, it is moving in 3D space. What's nice is it does retain the silhouette. It retains a lot of otherwise lost information. Just be careful with any shaders that require on normals, maybe consider baking. But also if it's requiring normals, you're actually also probably relying on a light position, in which case I would also recommend baking the entire color maybe to the mesh. I exclusively use this on objects that have an emission shader. Once we flatten to some degree, we can then offset where in space this is, understanding that going too far will again flatten some normals, and understanding that going too far in the other direction in the negative, we will begin to clip with the viewing plane. So I can't put hard boundaries on this because this number scales relative to this number where it begins to clip. And I didn't figure that out, so I apologize. However, really fast, in essence, what we're doing is we are setting the position of the object, literally just mixing the position, the original position, with the position of the camera, right? So we've got our active camera, we can grab its location, and then we can mix these two vector properties. Now, what makes this especially useful is that Z ordering the entirety of this plane offset. So what ends up happening is we can take the vector direction that this camera is pointing by rotating a downward facing vector into the rotation that the camera has. And then we can also find that line or that distance between the original location and the location of the camera by subtracting. And by normalizing this and then doing a little bit of linear algebra, we can then have what I think is a very intuitive feeling of, and it only really works when you have flattened in the camera space at all, but it allows you to modify how far or how close you are then asking that plane to be relative to its factor. Linear algebra gets a little fuzzy even for me, but in broad strokes, that is what we are doing, and I hope you enjoy using this in your own projects. Good luck and have fun.